Hi, my dear students. I am Mr. GopiKrishna. I have had the pleasure of teaching all the meritorious students in this country for the last 25 years in mathematics, particularly for IIT JEE Mains and Advanced. Every year, I support the activities of the students in doing well in all these examinations. And I would like to conduct a small course of 20 videos where I propose to discuss expected questions and concepts in mathematics, around 20 videos. And in the present video, we are about to discuss how to integrate modulus functions in a smart way. How to integrate modulus functions in a smart way. And each lesson is independent of the other lessons, and there are going to be 20 lessons of expected concepts and questions which are likely to appear in mains and advanced. And in the present class, we are about to discuss how to integrate modulus functions in a smart way. Alright, and you want to know what is the modulus function, right? Modulus gives the absolute value, that is modulus x is equal to x when x is greater than or equal to 0 and equals minus x for x less than 0. This you already know it. That means what I mean to say is that mod of minus 2, you have to use the lower branch. Since x is negative, you are getting 2. And similarly mod of 2 is also equal to 2. And if you draw the graph of this x-axis and the corresponding y-axis, is it going to be like a V-shaped graph or not? It's a V-shaped graph, and on the right side you have y is equal to x line, and on the left side you have y is equal to minus x. And this you already know it. Now for this branch, for the upper branch, can you tell me what is integral of mod x dx? And for the upper branch, when x is positive, it's going to be integral x dx, which gives me x square upon 2. And for the lower branch, I get integral of mod x dx equals minus x square upon 2. And if you notice it, I got two formulas for integral mod x dx. Integral mod x dx, which equals x square by 2 comma x greater than or equal to 0 and minus x square by 2 for x less than 0. And these two branches can be elegantly combined into one formula, and that is integral of mod x dx equals x into mod x upon 2. Take care. Now you have a simple formula, compact formula. Integral mod x dx equals x times mod x upon 2. Is it okay? Alright, continuing further, you have a ready-made formula, of course, for integral of mod x dx, and that is x times mod x dx. Okay. Now I would like to define one more function which is called signum x, sgn x. It gives the sign of the variable x. Signum x gives the sign of the variable x. It gives one of the three values, plus 1 when x is positive and is 0 for x is equal to 0, minus 1 for x less than 0. And this graph can be very easily drawn, right? For positive values, you have a horizontal line. You have a horizontal line whose value is plus 1, because on this side your x is positive. So on the other side, because x is negative, the output is going to be minus 1, and that will be minus 1. At x equal to 0, the value is 0. You have two horizontal straight line segments. Now, think about it for some time. Can this also be written like signum x is definitely a constant which can be one of the three values, and I can write a compact formula mod x upon x. For x is obviously division by 0 is not defined, for x is not equal to 0. So I have got one more formula, signum x equals mod x upon x for x is not equal to 0. Is it alright? Because after all, for positive x, mod x is going to be x and x then we cut. So you get plus 1 and you get plus 1 here. And for x is negative, mod x will be minus x and that will be minus 1. So it is getting tired, right? So now I have got one more interesting result, that mod x equals x times signum x. This is my method. Mod x equals x times signum x. Remember it. Now I gave you only two formulas, and the two formulas are that mod x equals x times signum x. Mod x is equal to x times signum x. Okay. Now once again, can you tell me? I need your involvement. First formula is the signum x equals mod x upon x, comma x is not equal to 0. And second compact formula is that integral mod x dx equals x into mod x upon 2. So integral of mod x dx is equal to x into mod x by 2. I'll let you use this definition for evaluating integrals. Right? We'll start with some simple example, and that is integral. Simple example. Example 1. Find, be careful, find integral minus 1 to 3 mod x plus mod x minus 1 dx. Mod x minus 1 dx. Majority of the authors, in all the books, what they do is that they split the integrand into various parts. Here the lower limit is minus 1, so this is minus 1, and the upper limit is 3. And upper limit is 3. So upper limit of integration is 3, and the lower limit is minus 1. And there is a critical point, mod x changes its behavior at x equal to 0, and x minus 1 also changes its sign at x equal to 1. That is how they do in majority of the books. And you get 3 cases here, right? 1, 2. When the value of x is in between minus 1 to 0, probably I can choose minus 0.5, which lies between minus 1 to 0 or not. So in that context, what is this? What is the output of mod x? Tell me. That's going to be negative, minus 6. So I will get here integral minus 1 to 3. Minus gets attached here, so I will get the output as minus x. And this guy is also negative. Negative sign gets attached. Minus x plus 1 dx. So that is how I have to split the integral between minus 1 to 0 in this interval. In the interval, my integrand becomes that integral minus 1 to 0 minus 2x plus 1 dx. Continue further, and I can write here minus 1 to 0. So value of integral is minus x square plus x, and the limits are running from minus 1 to 0. What is the value of this integral in that interval? Put the upper limit, that is 0. That will be 0, and put minus 1, 0, minus, and again put minus 1, minus 1, plus 1, minus 1, and x is minus 1, right? So again minus 1 here. So I am getting here the value of the integral as 2 in the first case. In the first case I am getting the value of the integral as 2. And can you tell me what happens in this interval between 0 to 1? Choose any value, that is 0.5. Which one is going to be positive here when I put x equal to 0.5? So the one in the modulus sign, x is positive. So the output is going to be, now you are between 0 to 1, right? So integral 0 to 1, okay, x, this guy is negative, so negative sign gets attached, minus x plus 1 dx. Okay, good. I got simply 1 dx, whose integral is x, and the limits are from 0 to 1, which gives me the value as simply 1. And between 1 to 3, what happens? In between 1 to 3, strange thing will happen here. Both are positive, and the limits are here 1 to 3, x positive, because it is between 1 to 3. X minus 1 is also positive because x is bigger than 1. So I get 2x minus 1. 2x minus 1 dx, because this is going to be x and that will be x minus 1. Adding them, you get 2x minus 1, and this will become x square minus x, and the limits are running from 1 to 3. Now can you tell me what happens now? What is the value for the upper limit? X square is 9 minus 3, that is 6, minus lower limit is 1 minus 1, which is simply 6. Simply 6. Now the complete integral, for the complete integral between minus 1 to 3, I have to add all of them, right? So that will be 2 plus 1 plus 6. So this will be 2 plus 1 plus 6, which gives me the answer as 9. This is exactly how it is being done by almost all the others, in all the textbooks also. But my approach is slightly different. Try to observe. I don't want to split the interval into various parts like this, which is cumbersome, right? And sometimes you may go wrong also. Alright. Now my approach is like this. Since I have a ready-made formula, right? And what is my ready-made formula? Once again, tell me. Integral mod x dx. You have to repeat in your mind at least. Integral mod x dx. Now repeat along with me. X times mod x upon 2. That is the fundamental idea here. And this is the smartest way. Now I can straight away write I equals x mod x by 2 plus x minus 1, corresponding integral mod x minus 1, whole thing divided by 2, and the limits are running from minus 1 to 3. No need to split the integrand. Straight away put the upper and lower limits here, and the upper limit is 3. When I put 3, this will be 3. Mod of 3 is again 3 plus 2. 3 minus 1 is 2. 2 into 2 upon 2 is the value when I substitute the upper limit. Minus lower limit, minus lower limit is minus 1. Minus 1. Mod of minus 1 is 1. So minus 1 multiplied with 1 and minus 1 minus 2 into 2 whole thing divided by 2. Okay. Proceeding further, I have here 9 plus 4, 13 by 2. 13 by 2, and that will be plus 5 by 2. Again I got the answer as 9, and this is much easier, right? You are not splitting the intervals, straight away applying the formula and proceeding further, right? Now, the same reasoning can be extended even for doing problems like this, hopefully. And that is, sometimes he may ask you a tricky question like this one, right? Integral e to the power of mod x dx. Okay. Hope you still remember that. I have one formula, mod x equals x into signum x, and signum x is a constant, right? It can be either minus 1, 0 or 1. So I will write here integral e to the power of x times signum x. So if you notice here, signum x is like a constant which is k. So integral is like e power kx, and you can easily tell me what is the value of this integral. Obviously e power kx upon k, and by the same reasoning I can write e power x into signum x, whole thing divided by the constant here. In this particular case it is signum x, right? Particular case it is signum x, and I can rewrite the same thing as e power mod x, because that is nothing but mod x, and signum x is mod x into x. So you got one more compact formula, and that is for e power mod x dx. E power mod x dx is this kind of formula. Can you also tell me what is integral of mod of sin x dx? I will be more than happy if you can. How do you write that? In place of x I have sin x, right? So straight away keep the integral sign here, mod sin x, use the same formula again. I am applying the same formula, this formula, and I can write sin x into signum sin x. Okay, very good. Signum sin x, and signum sin x can be taken outside the integration sign because that is like a constant, right? So this will be signum sin x. And what is integral of sin x dx? Basic integration minus cos x, right? Minus cos x. So now, so that is the formula for integral of mod sin x dx. Sometimes he may ask you that question also, tricky question. So in a compact form, probably I can write mod sin x upon sin x, because mod x, signum x is mod x by x into cos x, which gives me mod sin x into cot x. So that is the ready-made formula, compact formula for integral mod sin x dx. And the reasoning can be extended, right? Now you can try some of the problems on your own and to see, to understand the method. Try these problems. 1. Integral 1 to 4 mod x minus 1 plus mod x minus 2 plus mod x minus 4 dx. I am not bothered about the critical points 1, 2, 4. Straight away I can write the corresponding value x minus 1 into mod x minus 1 plus x minus 2 mod x minus 2 plus x minus 4 mod x minus 4 whole upon 2, and the limits are running from 1 to 4. Put the upper and lower limits here and you will get the answer as, you can verify it, the answer will be 23 by 2. Otherwise you have to split that into 5 parts, and that division is not at all required. Okay, you can try for practice one more problem also. Second problem for practice, integral, very long problem of course, integral 1 to 5. Now there are many moduli functions here, mod x minus 1 plus mod x minus 2 plus mod x minus 3 and plus mod x minus 4 dx. Limits are running from 1 to 5. See how many moduli functions are there? 1, 2, 3, 4. Can you tell me at least now what is the integral of mod x minus 2? X minus 2 mod x minus 2 upon 2. So you can write that value and you can establish that it is equal to 22. Please try it on your own. If you don't get it, in my next lesson, I'll solve these problems for you. Okay? One more also, for the sake, to get more confidence, you can try one more problem. Integral 1 to 4 mod x minus 1 plus mod x minus 2 plus mod x minus 3 dx, and the answer is 19 by 2. Okay, my dear students, the philosophy of all these lessons is to collect some important ideas which are expected in mains and advanced, and there are going to be 20 series of short sessions, right, keeping in view of this final examination. So try to understand them, and each lesson is independent of the other, so that way you can accumulate many ideas and they will be useful to you. And if we are fortunate, you may get 10 or 15 problems similar to them, and you will come out with flying colors like my old students. I wish you all the best. Okay, God bless you.